So this first one is actually not a proof at all. It's just solving kind of a practical problem with our angular relationships. So what does x need to be for those two lines to actually be parallel? How would I set this up? I think somebody could probably help me on this. If you want to turn your mic on or put it in the chat, either way. Yeah, they are equal to each other. This and this, if these are going to be parallel, then these are alternate interior angles. They're inside those parallel lines. So that is my equation. 2x plus 55 equals 3x minus 15. They have to be congruent. So yeah, it's going to be 70. I'm going to add the 15 over, get 70 there, subtract the 2x over, and get that 1x, or just x, is 70. You could always test to make sure that you did that correctly. If you plug in 70 here, well, that doesn't make any sense. That's bigger than 180, but so that I should have checked that before I just did that. But you can plug this in and make sure that that actually is equal to that. Right now that's 195, which doesn't really make any sense, but that would be 195 and that would be 195. So that's an easy way to check to make sure that you actually did that correctly. All right, when you get to your activity, it's going to look a lot like this. I think the first couple slides are problems that we just saw there. And then after that, you're going to see basically these just symbols that you can copy and paste. And all of our postulates and properties and definitions on one slide that, again, you can copy and paste. So these are the things that you're going to copy and paste into the reasons column. And these are the things that you can copy and paste for the statements. I'm not going to use this. I'm not going to copy and paste just because it's easier for me to write than it is for me to copy and paste. I guess if it's easier for you to type, that's fine. You can do that too. But I think it's just going to be easier if you have things, just a bank that you can copy and paste from. Make sure you don't cut and paste it. Otherwise, it won't be there when you're looking for it the next time. You're right. That is a lot. I would also encourage you to have what I call the toolbox ready so that you can use the definitions as you go. All right, so our first thing is that we are starting with the given statement. Here we have two given statements. L is parallel to M, and angle 1 is congruent to angle 2. It's not always clear which one to start with, but I'm thinking of how I'm going to prove that these two lines, A and B, are parallel. So in that picture, I see that if I can get to angle 3 and 2, if I can get to these two being congruent, then I basically have it. If those two are congruent, that's alternate exterior angles being congruent, which proves that my A and B are parallel. That's what you should always be thinking. How am I actually eventually going to get there? And then start with whatever steps you can, really. It's always going to be one of the given statements. Here, 1 and 2 being congruent doesn't really help us because they're separated by like 2 intersections. That's kind of how I'm viewing that. So this one is not that helpful quite yet. So I'm going to start with L is parallel to M, and that's my given statement. So I haven't said anything yet. Really, I've just said that this was given to me. That's going to be my starting point. What conclusion can I make based off of that given statement? Looking at the picture, if L and M are are parallel, what does that really tell me? What's another conclusion I can make from that? Yep, 1 and 3 have to be congruent. Those are corresponding angles. Given L and M, I'm ignoring B completely right now. I'm pretending that's not even there. I'm just looking at A as the transversal. This picture is a little bit confusing because there's two sets of lines. You really just want to completely ignore B right now. We're thinking about A as the transversal for these two parallel lines. So we know that 1 and 3 are congruent. Actually, Andy, we don't know that 2 and 3 are congruent yet. We will get there, but we can't say that quite yet. And this is a huge thing. Eventually, logics gets us there. But this is a huge thing that you need to be patient with proofs. You can't jump over steps. So how do we know that 1 and 3 are congruent? Let's just come up with a reason for 1 and 3 being congruent first off. I kind of already said it, I think, but somebody say it again for me. And you don't need to say out the whole thing. Yeah, they're not consecutive interior, they're corresponding. They're in the same spot with this one and this one as my two parallel lines. So that's my corresponding angles. Postulate. And I want you to phrase it like that. I don't want you to just say corresponding angles, because not all corresponding angles are actually congruent. It's only based on this postulate that corresponding angles, given that we have parallel lines, corresponding angles. Yeah, you could say theorem too. That's fine. Actually, either way is okay. Andrew, that's a good question. So when you take the SOL, you're not given like an answer bank of like what each thing means. But for my test, I want to see that you can use the logic of these things, and it's not requiring that you memorize these things. So I'm not going to require you to do that, but when you get to the SOL, you will. No, you don't have to do anything with the toolbox. The toolbox is just your answer bank kind of, or your word bank for right now. Yeah, it is basically like a dictionary. Okay, sorry. So we established that 1 and 3 are congruent because we have corresponding angles that are congruent when we have parallel lines. That's what this postulate really says. What can we do from here? So Andy was on the right track before, but we can't jump to that conclusion yet. Actually, Mohammed, that's exactly what we want to say. We want to say that other given statement here. We want to say that 1 and 2 are congruent. And that is the easiest reason that we have, because it was given to us. What do we do next from there? See, and again, if you say transitive postulate, I'm fine with that. It's really called the transitive property of congruency. Or if you're using an equation, then it's the transitive property of equality. Here, since we're dealing with congruency, you would say transitive property of congruence. I mean, I don't care. I would just say transitive property, to be honest. You can also use the substitution property here. If you imagine substituting in 3 for 1, you can also use the substitution property. Actually, they're kind of interchangeable at different times. Sometimes they're not, but there's a lot of occasions where you can use substitution and the transitive property interchangeably. So basically what we're saying here is if these two are congruent and these two are congruent, we can just jump over 1 and say that angle 3 is congruent to angle 2, which is what we needed to get to. That's confirming that this and this are congruent. So what's that last reason? So really, we're at our proof, actually. A and B are parallel because yep, Avi, that's it. It's the converse of alternate exterior angles, or the alternate exterior angles postulate. And you absolutely have to say the converse part of that. I know that you're seeing exterior angles here, and it might be just a natural inclination to just say what you have, but that postulate actually said, oops, not plural, that postulate actually says that if we have parallel lines, then we can get to the angles. The converse of that is saying that if we have the angles, we can get back to those lines being parallel. So this is the conclusion that we can make based off of that reason. All right, I'm going to move on. Any questions about that actually before we move on? And if that's still hurting your brain, that's okay. This is just really the first example that we've seen. So we're going to do 3 more of these, and then you're going to try to practice on your own. If you want to be fancy about this. In a math proof, I think these mean the exact same thing, but you can say QED. Actually, I'm not sure what that stands for. Or you can put these little dots. And that basically means I've proved it. It's as close to a mic drop as a mathematician will ever get. All right, so we're trying to prove that lines K and J are parallel. Well, there's no labels, but that's J and K. Given that M has a measure of 53, sorry, 1 has a measure of 53, and 2 has a measure of 127. So that and that, we're given those angle measurements, we want to get to those two lines being parallel. So at least we know where we're starting. We're given those two measures, and I could just say that as one thing. So I'm going to start off with those as my given statements. What can I conclude based off of that? That's jumping a lot of steps. So you're right, eventually we are going to get there. But, oh wait, well, okay, sorry, Muhammad. 1 and 2 are corresponding exterior angles. You can't really say that yet because we don't know that these are parallel lines. And Avi, you're just jumping to what we want to get to, but we haven't actually established that we have supplementary angles yet. And yes, I know in your head you know that those are supplementary, but you have to say that those are supplementary. And even before we say that they're supplementary, what says that something's supplementary? Like, yeah, there we go. Yep, you do have to take those steps. So 53 plus 127 is 180. And what is that? Why am I allowed to do that step? Yeah, what's the mathy or geometry way? Close. What kind of addition? Actually, not quite by the definition of supplementary angles. That's going to be our next reason. What allows me to say 53 plus 127 for angles equals 180? What allows me to add these up? Yeah, it is a brain. That's true. I know some of these are going to seem silly that you have to explicitly say it, but the angle addition, yeah. The angle addition postulate allows me to add two angles together and actually get the total. So now I could say that they're supplementary. Actually, Andy, there is another way that you could do this with corresponding angles here, but I don't even want to use 3 if I don't need to, because right now I can already say that angle 1 and angle 2 are supplementary. Almost, Avi. We got one more step. We just have to actually say that these are supplementary, because this isn't saying that they're supplementary. That's just saying that they add up to 180, which obviously means that they are supplementary. That's what we're about to say. By the definition of supplementary angles, we can say that they're supplementary. And now we can actually say, since they're supplementary, we can conclude that these are parallel lines by that converse. So we can actually conclude that now. Yes, Abby, that is where I see the biggest problem coming in here, that it's not the logic that gets in the way. It's actually taking those small steps that you actually do need to explicitly state. This is one of the more picky types where you actually have to say, yeah, we're allowed to add up angles. It's like, that seems like a given, but there's nothing that's a given. Well, there are some things that are given, literally, but there's nothing that you should be assuming your way past. You should always be stating every single step, and sometimes it seems like it's even too much, but you can't ever state too much in a proof, honestly. All right, I think we can just try the next one. I think I have two more of these. So we have these two angles, 1 and 2 are congruent, and 2 and 3 are congruent. So actually just based off of that, you might be able to see what you can do right there. But we want to eventually get to 1 and 4 being congruent. So there's different ways that you could start this. Actually, there's different ways that you can start a lot of these. So, Sean, to get to 1 and 3 being congruent, let's just state those two given things. So that's given. That's given. And then I'm guessing you want to use the transitive property to get there. Just jumping over 2. You could also use the substitution property, actually. That's the same thing there. So how does that help us there? Knowing that 1 and 3 are congruent. Andy, how do we know that 3 and 4 are congruent? I don't know that those angles are actually congruent, though. I don't have parallel lines yet. Yeah, just like I said, we have to prove that those are parallel lines. I don't know that any of these lines are actually parallel yet. So I can't say that I have congruent corresponding angles. Yes, Ryan, absolutely. At times this is nitpicky. Okay, so Abi, what does that give us? Which two lines are parallel based off of that? All right, so I'm hoping everybody sees what we're talking about there. These two lines have to be parallel because these two, we know they're congruent. So by the converse of the alternate exterior angles, we know that those are parallel. Yeah, it is really just switching the implication and the assertion, I guess, the hypothesis and the conclusion. Instead of going from parallel lines to the angles, you go from, I have these angles, so I know that these two are parallel lines. If you're given the angles, if you know that we have congruent angles and you want parallel lines, that's when you're reversing them. That's when you're thinking about the converse. No. Oh, I thought you had a typo. I'm sorry, Agatha. Sorry. All right. So we now know that C and D are parallel. Now we can do corresponding angles. Because if these two lines are parallel, now we know that 3 and 4 are congruent. So now we can do the straightforward corresponding angles. Now, what's next? Yeah, actually, Muhammad, Ryan, either of those is good. And AJ, same thing. A lot of the times that is kind of what you're doing. Your reasons, like this, is based off of what just happened. So this statement basically generated that reason. But exactly what everybody just said there. Transitive or substitution property. we can basically hop from 1 over 3 to 4. So we know that 1 and 4 are congruent. And we are done. All right, we're gonna do one more together. All right, we know that A and B are parallel, and that 5 is supplementary to 2. Whenever they're separated like across these different sets of lines, like 5 to 2, you're usually not going to start with that one. It's just too hard to make that jump right away. That'll be helpful later, but I know that my first given there, A and B, is where I'm going to start. And there's more than one way to start this one. There's a bunch of different ways to start this one, actually. Where do you guys want to start? A and B being parallel, what does that help us conclude? 3 and 4 are corresponding. Yeah, let's just start there. And sometimes there's faster, angle 3 and 4, or 3 and 7. 3 and 7 are corresponding. And actually, what Javi brought up before, I want to even reiterate that here. This statement tells us how we're going to proceed from there. Knowing that these are parallel, that says we're allowed to use that postulate. That is the basically the assertion or the hypothesis of that. 5 and 7 are corresponding, but I don't know that yet. I don't know that until I have parallel lines here. L and M, I don't know if they're parallel. 1 and 5 are corresponding. I'm not sure if that's going to help us, though. We could say that 1 and 5 are corresponding. Just not sure how that gets us to where we need to go. Muhammad, I can't say that those are actually congruent yet. If I don't know that L and M, these two, are parallel, I don't know anything about the relationship between these two intersections yet. 5 and 6 are congruent. That's a good one. Okay, we can also say the second given statement. You want to try that? I mean, really, I'm not exactly sure what the fastest way is going to be, but let's try that, saying that 5 and 2 are supplementary. And that's a given. What does that help us conclude? So are 4 and 2 just by the definition of a linear pair. You want to do that next, Josh? That might be helpful. But before I even get into that, maybe, what does this given statement tell me? What are supplementary angles, really? There's one part that we're missing of that. Yeah, they add up to 180. We actually need to state that part. I think that's going to be one of the things that trips us up, just not stating that. Like, I know that you know that they add up to 180, but you actually have to say it. So angle 5 plus angle 2 equals 180, and that's just by the definition of supplementary angles. You do need to state both that it's given and that you know what supplementary means, basically. Not that you know what it means, but that you know the conclusion that comes from them being supplementary. These are actually two completely different things. Saying that they add up to 180 and saying that they're supplementary, they're very similar, but one's a naming of it, one's an actual operation with those angles, and you do need to say both. All right, I feel like we got jumbled up a little bit because a lot of people were saying things that we will eventually conclude, but not exactly what we can, or things that we could conclude, but might not actually lead to what we need. And actually, once we pick this route to go, we kind of narrowed our pathway a little bit. What do we want to do from there? So before class, I wrote out my proofs for each of these, but I'm not exactly sure this was the route I took. Yeah, it's not actually, but that's okay. Maybe let's go back. What can we definitely say? What can we absolutely say with certainty, knowing that these are parallel? Because somebody might have said it before and I just don't recall it. 3 and 5 is congruent. They are, but we just can't conclude that quite yet. What else do we know about 3, maybe? The only corresponding angles we actually have right now is 3 and 7. There you go, Josh. That's really what I was looking for. If we know that, yeah, we have the linear pair there, 2 and 3. If we know that these make a straight line, just by the definition of linear pair, we could say that 2 and 3 are supplementary, and I'm going to be annoying again, but you have to say one more reason here. Or sorry, one more statement here, not one more reason. Well, every reason needs a statement. By the definition of supplementary, we know that these two add up. That's sloppy. Sorry, one more second. They add up to 180. Where do we go from there? That's true. Yeah, I don't know if that helps either. That's what I was kind of thinking. It's like, that's definitely true. And 3 and 4 are congruent also because of vertical angles. I'm not sure where that would take us though. When I see these two equations, if I see equal equations like that, I don't know if they are, but yeah, that is where we're going to go. They are congruent, they're corresponding and congruent, but we actually don't know that yet because we don't know that that is parallel to that. But when I see these two equations, I'm going to take this. If I know that that equals 180, I can take this and substitute it in place of that 180. So I'm going to use the substitution property here. And say that angle 5 plus angle 2 is equal to angle 2 plus angle 3. The converse of APO. I'm not exactly sure what the converse of APO would be. Really, I would just use ESPO. I would just subtract, yeah. I would just subtract the angle 2, the measurement of angle 2 on both sides. So I'm going to keep going over here. My statements, my reasons there. So I'm using ESPO to get that angle 5 is congruent to angle 3 by ESPO. Oops, ESPO. And now what? All the way in the beginning, I'm using the transitive property from that second statement with this statement and saying that 5 and 7 are congruent. Again, transitive property there and substitution are actually the same thing. And then, at least we're at our last one. If 5 and 7 are congruent, yeah, then we can use the not corresponding exterior, just corresponding. The converse of, I'm going to run out of room here. So if I know that that and that are congruent, these two lines have to be parallel. And that's basically working backwards from angles to the parallel lines. That's why it's the converse of that. And that actually does prove that L is parallel to M. So I wanted to show you something that was tougher. I will say that that's the most steps that we had to do in any of ours, and it's probably more steps than you'll have to do in any of the ones that you practice with. But I did want to show you how long it might have to take, just because you do need to set out all of those nitty-gritty little things sometimes that you feel like you already know, but don't ever assume something and just move on from it. State it. All right, so I'm going to share with you the activity. Actually, I'm going to put it in Google Classroom too, but I'm also going to just share the link. Actually, maybe I don't want to do that. Maybe I want you to actually go to it in Google Classroom, just so you can actually turn it in there. I'll share the link with you once I actually assign it in Google Classroom. Give me 1 second.